This is the coefficient of friction activity setup video. This is a simple setup for this lab. You simply have a board where you remember to put the wooden side down. You'll have a weight. The first weight will be 5 kilograms. We will work our way up to 9 kilograms. You'll have a string. A lot of these have long strings that we'll use later in different labs, but you should have a loop here. You don't want to, it's probably easier to have a shorter connection, so you have your force probe connected to that, and then your force probe into your LabQuest. All of this equipment we've used before. You'll either be on a table like this, or you may be on one of the black countertops. Basically what we're looking at doing is this situation. So here's my wood with the weight on top. I've got the force of the probe is pulling to the right. Since we're not accelerated other than right at the beginning, we speed up, but then we want constant velocity. I mean, to go from not moving to moving, I obviously have to accelerate, but that only lasts for a short millisecond. So basically my forces are balanced, and the force of the probe has to match the force of friction. There's two forces of friction. Before I start moving, I have a static. That means not moving. So my force of friction is equal to F sub S. That's the static friction. Once I start moving, my force of friction is equal to the moving force of friction, which is kinetic. So that's F sub K. We will find a formula later that shows us that we need the force of friction depends on two things. It depends on the surfaces that are dragging, and that turns out to give you your coefficient of friction, which we'll talk about later. And it turns on the normal force. Again, this block is not floating up in the air. It's not going through the table. So my force of normal of the table pushing up matches the force pulling down, which is the force of gravity, which is the mass, the total mass times the gravity. And that's the basic setup for this lab.